Welcome to Get Your FRQ On. This question is from 2011, Form B. It's question 5, and it is not calculator active. In the question stem, we've got a character Ben riding a unicycle back and forth along a straight east-west track. There's a twice differentiable function B that models Ben's position on the track, measured in meters from the western end of the track, at time t, measured in seconds from the start of the ride. There's also a table that gives values of b of t and Ben's velocity v of t measured in meters per second at selected times t. In part A of this question, we are asked to use the data to approximate the acceleration at time t equals 5 seconds and to provide the appropriate units. Ben's acceleration at time t equals 5 seconds can be approximated by finding the value of v of t minus v of 0 over 10 minus 0, which is 2.3 minus 2 over 10 minus 0, or 0.3 over 10, which is just 0.03. So Ben's acceleration at time t equals 5 seconds is approximately 0.03 meters per second per second. In part B of this question, we are asked to interpret the integral from 0 to 60 of the absolute value of v of t dt and to approximate it using the left-hand Riemann sum. First, the integral from 0 to 60 of the absolute value of v of t dt gives the total distance in meters that Ben travels between the times of t equals 0 and t equals 60 seconds. To approximate the integral from 0 to 60 of the absolute value of v of t dt, we have 2 times 10 plus 2.3 times 30 plus 2.5 times 20, which gets us 20 plus 69 plus 50, which is 139. From this, we can conclude that the total distance Ben traveled between time t equals 0 seconds and time t equals 60 seconds was 139 meters. In part C of this question, we are considering the closed interval from t equals 40 to t equals 60 seconds. We are asked if there must be a time in this interval where Ben's velocity was exactly 2 meters per second, and to provide justification for our answer. We are given in the question stem that Ben's position function is twice differentiable. So we compute b of 60 minus b of 40 over 60 minus 40, which is 49 minus 9 all over 20, or 40 over 20, which reduces to 2. Using this result, the mean value theorem guarantees that yes, there is some time t between 40 and 60, such that v of t is exactly equal to 2. In part D of this question, there is a light introduced, and we are asked to find the rate at which the distance between Ben and this light is changing at t equals 40 seconds. Now, while we are not given a specific function for this new light that's been introduced, we are given that it satisfies the equation L of t squared is 144 plus b of t squared. So what we have here is a related rates problem. If we differentiate, 2 times L of t times L prime of t is equal to 2 times b of t times b prime of t. So 2L of t times L prime of t equals 2 times b of t times v of t. And this implies that L prime at 40 is 2 times b of 40 times v of 40 all over 2 times L of 40. Substituting the values for those in, we get 9 times 2.5 all over the square root of 144 plus 81. Simplifying that, we get L prime of 40 is 22.5 over 15 meters per second. I think that simplifies to 3 over 2, but you don't have to simplify, so it didn't. And so that is the rate at which the distance between Ben and the light is changing at t equals 40 seconds. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.